Hello student, now this is the variation chapter. I will explain all the exercise, that is a 7.1, 7.2, 7.3 in a very simple language, and I hope that you will understood all the problems whatever that I explained. Now let us start the chapter variation. And now let us start the variation chapter number 7. Let's study and also let's recall. If the rate of notebooks is rupees 240 per dozen, what is the cost of 3 notebooks? Also find the cost of 9 notebooks, 24 notebooks and the 50 notebooks, and complete the following table. The number of notebooks 12, 3, 9, 24, 50. Okay. Next is the cost of notebooks, that is a 240, and the last is 20. From the above table, we see that the ratio of number of notebooks X and their cost Y in each pair is 1 upon 20. Here you can see this is 1 upon 20. That is a 12 upon 240 is equals to 1 upon 20. From the above table, we see that the ratio of the number of notebooks X and their cost Y in each pair is 1 upon 20. It is a constant. The number of notebooks and their cost are in the same proportion. In such a case, if one number increases, then the other number increases in same proportion. Now, what is meant by the direct variation? The statement X and Y are in the same proportion can be written as X and Y are in the direct variation, or there is a direct variation between X and Y. Using mathematical symbol, it can be written as X is a proportional to Y. This is the sign for the proportion, where the symbol, again I will repeat, using mathematical symbol, it can be written as X is proportional to Y, where alpha is a Greek letter used to denote the variation. X is proportional to Y is in the form of the equation as X is equals to KY. This is the statement, and in the form of the equation it is written as X is equals to KY, where K is a constant. Okay, X is equals to KY, or X upon Y is equals to K. Here Y is multiplied to K and it is written as X upon Y is equals to K is the equation form of the direct variation, where K is called the constant of variation. Observe how the following statements are written using the symbol of variation. Area of circle is directly proportional to the square of its radius. If the area of the circle is capital A, its radius is a small r, the above statement can be written as A is directly proportional to r square. Pressure of a liquid P varies directly as the depth of the liquid. This statement is written as P is directly proportional to D. If we go deep and deep, then the pressure is increases. To understand the method of the symbolic representation of the direct variation, study the following examples. What is the first example? X varies directly as Y. When X is equals to 5, Y is equals to 30. Find the constant of variation and the equation of variation. Now the solution. X varies directly as Y, and it is written as X is directly proportional to Y. This is the statement, and the equation is X is equals to KY, where K is a constant of variation. Now when we have given that when X is equals to 5, Y is equals to 30. Now substitute here X is equals to 5 and Y is equals to 30, and then you will get 5 is equals to K into 30, and therefore K is equals to 5 upon 30, and that's equals to 1 upon 6. This is the constant of variation. Equation of the variation is x is equals to ky, that is x is equals to y upon 6, or y is equals to 6x. This is the equation of the variation. Now the next example. Cost of the groundnuts is directly proportional to its weight. If the cost of 5 kg groundnuts is rupees 450, then find the cost of 1 quintal groundnuts. See, this one more thing is that 1 quintal means what? 100 kilogram. Now the solution. Let the cost of groundnuts be x and the weight of groundnuts be y. It is given that x varies directly as y. Therefore, x is directly proportional to y. X is equals to ky. It's a given that when x is equals to 450, then y is equals to 5. Hence, we will find the k. X is equals to ky. Therefore, 450 is equals to 5k, and that's why k is equals to 90. And it is called the constant of variation. Equation of the variation is x is equals to 90y. If you want to find out the cost of y is equals to 100 kilogram, then x is equals to 90 into 100, and that is equals to 9,000, and hence the cost of 1 quintal groundnuts is rupees 9,000. These are the very simple examples of the direct variation. Now see this in this table, you can fill in the blanks, and this is you have the exercise. Now we'll see the exercise 7.1. Write the following statement using the symbol of the variation. What is the first? The circumference C of a circle is directly proportional to its radius. Therefore, C is directly proportional to R. This is the first one. Consumption of the petrol L in a car and the distance traveled by that car D are in the direct variation. Therefore, L is directly proportional to T. Next problem. Complete the following table considering that the cost of apples and their number are in direct variation. The number of apple and the cost of apple. One apple, 8 rupees 8. Okay, and in this way, now next fill in the blanks. The cost of apple Y and their number are in direct variation. Therefore, Y is directly proportional to X. Therefore, Y is equals to Kx, where K is a constant of variation. And this is the equation. Now first we have given that the number of apple is 1 and the cost is 8. Therefore substitute here, that is x is equals to 1 and y is equals to 8. Therefore 8 is equals to k. Okay, here k is a constant of proportionality. Put the value of k is equals to 8 in equation number 1. Therefore you will get y is equals to 8x. By using this equation, let's find the fill in the blanks. Okay, in the table that we have given. Now what is first? That's the cost of apple, means we have given the value of y. Then find x. Okay, now here when y is equals to 56, then what is the value of x? We know the equation of the direct variation. Y is equals to 8x. Now substitute here, y is equals to 56. Therefore 56 is equals to 8x, and hence x is equals to 56 upon 8, and hence x is equals to 7. What about the next? When x is equals to 12, then find the value of y. Again the equation is y is equals to 8x. Substitute the value of x, that is 8 into 12, then you will get y is equals to 96. Now the next, when y is equals to 160, then find the value of x. Now put again the in above equation. What is that? Y is equals to 8x. Okay, and if we substitute here y is equals to 160 is equals to 8x, therefore x is equals to 160 upon 8, and hence x is equals to 20. Now the completed table is this. That is the number of the apple 1, its cost is 8, 4, 32, 7, 56, 12, 96 and 20, 160. Now the problem number 3. If m is directly proportional to n, when m is equals to 154, n is equals to 7, find the value of m when n is equals to 14. Now here m is directly proportional to n. This is the statement. Next, therefore m is equals to kn, where k is called the constant of variation. This is equation number 1. Now next, see this here. The value of m we have given. M is equals to 154 and n is equals to 7. Substitute here m is equals to 154, n is equals to 7. And then you will get k is equals to 154 upon 7 and that is equals to 22. Put k is equals to 22 in this equation. Then you will get m is equals to 22n. Now, when n is equals to 14, put here in this equation. Then n is equals to 14. Then find out the value of m. That is that 22 into 14 is equals to 308. And hence, when n is equals to 14, m is equals to 308. Now the next problem. If n varies directly as m, complete the following table. M is 3, n is 12, m is 5, n is 20, m is 6.5. Then what is the value of n? When n is 28, then find out n. When m is 1.25, then find the value of n. Now this is the solution. That is, n is directly proportional to m. This is the statement. Therefore, n is equals to km, where k is a constant of variation. Now, firstly, we have given that when m is 3 and n is 12. Substitute the values. n is 12 and m is 3. Then you will get 12 is equals to k into 3. Therefore, k is equals to 12 upon 3 and hence k is equals to 4. Therefore, the equation of the given equation is equation of the variation is n is equals to 4m. Okay. Now we will find out when m is equals to 6.5, then find it. Therefore, substitute the value of m is 6.5 in our equation. Okay. Then you will get n is equals to 4 into 6.5 and their product is 26. And hence n is equals to 26. Now again, when n is equals to 28, then again here we will use the equation n is equals to, what is that equation? N is equals to 4m. Substitute the value of n, that is the 28. Therefore, m is equals to 28 upon 4. Therefore, m is equals to 7. Next, substitute the value of m is equals to 1.25. Now again, what is the equation? N is equals to 4m. Substitute the value of m. Then you will get n is equals to 4 into 1.25 and that n is equals to 5. And the completed table is this. When the value of m is 3, n is 12, m is 5, n is 20, m is 6.5, n is 26, m is 7, n is 28, m is 1.5, n is 5. Now the problem number 5. Y varies directly as a square root of x. When x is equals to 16, y is equals to 24. Find the constant of variation and the equation of the variation. Now we have given the statement y varies directly as the square root of x. Therefore, y is directly proportional to square root of x. Now next, this is the statement. Therefore, the equation of the variation is y is equals to k into root of x, where k is a constant of variation. Now also we have given x is equals to 16 and y is equals to 24. Substitute the values. X is equals to and y is equals to. Y is 24 and x is 16. The square root of 16 is 4. Therefore, k is equals to 24 upon 4. You will get the value of k is a 6. Therefore, the equation of the variation is a y is equals to 6 root x. This is the equation of the variation. And hence, the constant of variation is 6 and equation of the variation is 6 root x. The total remuneration paid to the laborers employed to harvest soybean is in the direct variation with the number of laborers. If the remuneration of the 4 laborers is rupees 1000, find the remuneration of the 17 laborers. Let the remuneration paid be X and the number of laborers be Y. Therefore, X is proportional to Y. This is given. That is, therefore, X is equals to KY. This is the statement. This is the equation. We have given that first. That is there are the 4 laborers and remuneration given is 1000. There is put here that is Y is equals to 4 and X is equals to 1000. Therefore, 1000 is equals to K into 4. Therefore, K is equals to 1000 upon 4. And hence, K is equals to 250. And this is the constant of variation. Therefore, X is equals to 250 into Y. This is the equation of variation. When Y is equals to 17, now substitute here. Then you will get X is equals to 250 into 17. And hence, X is equals to 4250. Okay. Therefore, the remuneration of the 17 laborers is rupees 4250. Okay. And in this way, the first part of the exercise, that is the 7.1, we have completed. Now, the next. The following table shows the number of rows and the number of students in each row when they are made to stand for the drill. Again, I will repeat here. The following table shows the number of students in each row. Number of the students in each row is 40. Then the number of rows are 6. Number of rows are 10. Number of the students in each row is 10. Then the number of rows are 24. Number of students in a row is 24. Then the number of rows are 10. Number of students in a row is 12. Then the number of rows is 20. And the last is number of students in a row is 8. Then the number of rows is 30. Okay. Now from this table, you can observe that if the number of students in a row is big one, that is 40, then the number of rows are less. Now see this here. Number of the students in a row is 8. Therefore, number of rows are more. That is 30 rows are there. From the table, we observe that the product of the number of students in each row and the total number of rows in each pair is 240. That is the number of the student in a row and the number of the rows. If you make their product, that is 40 into 6, then you will get 240. 10 into 24, then you will get 240. 24 into 10, again you will get 240. And in this way, the number of the student is a constant. Which is constant? It means the number of the student in a row and the number of the rows are in inverse proportion. If the number of rows are more, then the number of the student in each row is less. If the number of the student in row is more, then the number of rows is less. Okay. जर एका ओळीमध्ये असणाऱ्या विद्यार्थ्यांची जर संख्या जास्त असतील तर रो कमी करावे लागतील आपल्याला. परंतु जर समजा एकाच ओळीत फक्त 8च विद्यार्थी असतील तर आपल्याला रोची संख्या, रांगांची संख्या कशी असणार आहे तर वाढवावी लागणार आहे. ओके. Is again see this. It means that the number of the student in a row and the number of the rows are in inverse proportion. In a pair of student, in a pair of numbers, if the increase in one number causes decrease in the other number in the same proportion, the pair is inverse variation. That type of the pair is inverse variation. Pair means what? 40 and the 6. This is the pair. If one number increases, the other number decreases. Now this is a 10, the other is increased. This is a 24, again it is a decrease. Okay. Now you can see this here. If a pair of numbers, if the number in one, if the increase in one number causes decrease in the other number in the same proportion. The pair is in inverse variation. In such examples, if one number of the pair is double, the other is haven't. Okay, now see this there, inverse variation. The statement x is inversely proportional to y can be expressed as there is an inverse variation in x and y. If x and y are in inverse proportion, if x and y, I will repeat again here, if x and y are in inverse proportion, then x into y is constant. Assuming the constant to be k, it is easy to solve a problem. If x varies inversely as y, then x into y is constant. X is inversely varies as y is written as x is inversely varies as y. If x is inversely varies y, then this is the statement x is inversely proportional to y. This is the statement and it can be written as that is a x is equals to k upon y, and therefore we will get here x into y is equals to k. Therefore x is equals to ky. Now this is the correct one. If x is inversely proportional to y, therefore we can write here x is equals to k upon y, or it is written as x is equals to k into 1 upon y. Therefore k is equals to x into y. This is the equation of the variation where k is a constant of variation. Now see this solved example. If a varies inversely as b, then complete the following table. The value of a are 6, 12, 15. Okay, the value of b is a 20. Then find out all the remaining values. Now see this here, the product of a into b, that is a 6 into 20, a into b is equals to 120. Okay, now here a is inversely proportional to b. This is the statement, and again it can be written as a is equals to k upon b, and again it can be written as a into b, that is equals to k. Same here, a into b is equals to k. Now first we have given that the value of a is 20, and a is a 6 and b is a 20. Now substitute here a is a 6 and b is a 20. Therefore k is equals to 6 into 20, that is equals to 120. Now when a is equals to 12, then what is the value of b? Okay, now see this here, the equation of the variation, that is a into b is equals to 20. The value of a is a 12 into b is equals to 120. Therefore b is equals to 10. When a is equals to 15, then find the value of b. Therefore a into b is equals to 120. The value of a is 15 into b is equals to 120, and hence b is equals to 120 upon 15, and hence a is equals to b is equals to 8. Now the next, when b is equals to 4, then what is the value of a? We know that a into b is equals to 120. Again, substitute the value of b, which is 4. Therefore a into 4 is equals to 120. Therefore a is equals to 120 upon 4, and the value of a is equals to 30. And in this way we can find out all the values. Now the next problem, that is f is inversely proportional to 1 upon d square, inversely proportional to d square. The value of d is 5 and the value of f is 18. Okay, now first, if d is 10, then find f. Second, f is 50, then find the d. Now f is inversely proportional to d square. Therefore this is the statement, and again it can be written as f is equals to k upon d square, and again it can be written as f into d square is equals to k. When d is equals to 5, f is 18. Substitute the value of d and f here, that is 18 into 5 square is equals to k, and therefore you will get 18 into 25, and that is equals to 450, which is the constant of variation. Okay, now find out f when d is equals to 10. Now what is the equation of the variation? That is f into d square. F into d square is equals to 450. Now substitute the value of d as a 10. F into 10 square is equals to 450. F into 100 is equals to 450, and therefore f is equals to 4.5. When f is 50, d is question mark. f into d square is equals to 450. What is the value of f? F is 50 into d square is equals to 450. Therefore, d square is equals to 450 upon 50 and d square is equals to 9 and hence d is equals to plus or minus 3. Now we'll see the exercise 7.2. The information about the number of workers and the number of days to be complete a work is given in the following table. Complete the table. The number of workers is 30, number of days are 6. The number of the workers are 20, the number of the days are 9. When the days are 12, find out the number of workers. When the number of workers are 10, find the number of the days. When the number of days are 36, find the number of workers. Now let here the number of workers be n and the number of days is d. Now here n is inversely proportional to d. Again n is equals to, what we will write here, n is equals to k upon d. Okay, therefore n into d is equals to k. Now first we have given that the number of workers n is equals to 30, that is n is equals to 30 and the days are 6. Therefore substitute here n is equals to 30 and d is equals to 6. Therefore k is equals to 180. Now next, when d is equals to 12, then what is the value of n? N into d is 180. Substitute the value of d. N into 12 is equals to 180. Therefore n is equals to 180 upon 12 and hence n is equals to 15. Now the next, when n is 10, what is the value of d? N into d is 180. N is 10 into d is equals to 180. Therefore d is equals to 180 upon 10 and hence d is equals to 18. Now the next, d is equals to 36. Then what is the value of n? N into d is 180. Therefore substitute the value of d, that is n into 36 is equals to 180. Therefore n is equals to 180 upon 36. Hence n is equals to 5. Next, the completed table is number of the workers 30, the days are 6. Number of workers are less, the days are more, which is 9. Again the number of workers are less, 15. Again the days are more. Again the number of workers are less, then the days are again increases, and again number of workers from 10 to 5, the days are increased by the twice. Okay. Find the constant of variation and write the equation of the variation for every example given below. Now P is inversely proportional to Q. When P is 15 and Q is equals to 4. Now here P is inversely proportional to Q. Therefore again we can write here that the P is equals to K upon Q. Therefore again it is written as P into Q is equals to K. Now we have given that P is 15 and Q is equals to 4. Substitute here P is 15 and Q is equals to 4. Therefore K is equals to 15 into 4. That is the K is equals to 60. Therefore this is the equation of the variation. What is the equation of the variation? P into Q is equals to 60. Next, Z is inversely proportional to W. When Z is equals to 2.5 and W is equals to 24. Now again, this is the Z is a inversely proportional to W. Again it can be written as Z is equals to K upon W. And therefore the equation of the variation is Z into W is equals to K. When Z is equals to 2.5 and W is equals to 24. Substitute their values. That is a 2.5 and W is 24. That's equals to K. Therefore K is equals to 60. This is the constant of variation. Okay. Z into W, that is equals to 60. This is the equation of the variation. Now next, S is inversely proportional to T square. When S is 4, T is equals to 5. Again, the statement is S is inversely proportional to T square. Therefore S is equals to K upon T square. And the equation of the variation can be written as again S into T square is equals to K. When S is equals to 4, T is equals to 5. Substitute here S is equals to 4, T is equals to 5. 5 square is 25. 25 into 4. Therefore you will get K is equals to 100. Therefore the equation of the variation is substitute the value of K in this equation. That is S into T square is equals to 100. Now the fourth problem, X is directly inversely proportional to Y. When X is 15, Y is equals to 9. Substitute here again the value, that is x is equals to k upon y. Therefore x into y is equals to k. Now when x is equals to 15, y is equals to 9. Substitute here 15 and 9. Then you will get k is equals to 135. This is a constant of variation. And substitute the value of k here, 135. Therefore x into y is equals to 135 is the equation of the variation. Now the next problem. The boxes are to be filled with the apples in a heap. If 24 apples are put in a box, then the 24 boxes are needed. If the 36 boxes are filled in a box, then how many boxes will be needed? Now see this here. The number of apples in each box is equals to x. Number of the apples in each box is x, and y is the number of the boxes. Now x is inversely proportional to y. Okay. Therefore x is equals to k upon y again here. Therefore x into y is equals to k. When x is equals to 24, y is equals to 27. Therefore x into y, that is the 24 into 27 is equals to k. And their product is 648. This is the constant of variation. And hence its equation can be written as x into y is equals to 648. But when x is equals to 36, then what is the value of y? That is the number of the boxes. Now in this case, we have increased the number of the apples in box. Therefore, substitute the value of x is equals to 36 into y is equals to 648. Therefore, y is equals to 648 upon 36, and its division comes to be y is equals to 18. If the 36 boxes are placed in each box, then the 18 boxes are required. Now the next problem, write the following statement using symbols of variation. The wavelength of the sound is L and its frequency f are in the inverse variation. Now again I will repeat this problem. The wavelength of sound L and its frequency f are in inverse variation. That is L is inversely proportional to f. The intensity I of light varies inversely with the square of the distance d of the screen and the lamp. Therefore, here I is inversely proportional to d square. Now next problem number 5. X is inversely proportional to y. When x is equals to 40, y is equals to 16. Then find the value of y when x is equals to 10. Now x is inversely proportional to y, and therefore it is written as x is equals to k upon y. When therefore the equation of the inverse variation is x into y is equals to k. When x is equals to 40, y is equals to 16. Therefore here substitute the value of x is 40, y is 16. Therefore you will get k is equals to 640. X into y is 640 is the equation of the variation. When x is equals to 10, then what is the value of y? Put x is equals to 10 here. 10 into y is equals to 640, and hence y is equals to 640 upon 10, and hence y is equals to 64. Therefore, when x is equals to 10, y is equals to 64. Next problem, x varies inversely as y. When x is 15, y is 10. X is 20. What is the value of y? X is inversely proportional to y, and hence x is equals to, you can write here, k upon y. X into y is k. Therefore, substitute the value of x is 15 and y is 10. Then you will get k is equals to 150. X into y is equals to 150. When x is equals to 20, then what is the value of y? Therefore, 20 into y is equals to 150. Therefore, y is equals to 150 upon 20. And that comes to y is equals to 7.5. And when? In this way, that is x is equals to 20, y is equals to 7.5. And in this way, we have completed the exercise 7.2. Also practice set, that is 7.2 also. Now the next type of examples is time, work and the speed. Examples related to the number of the workers and the time taken to finish the work are in the inverse variation. Similarly, there are some examples related to the time taken to cover a distance. I will again repeat here. Similarly, there are some examples related to the time taken to cover a distance by a vehicle and its a uniform speed. Such examples of the variation are the examples related to time, work and the speed. Now we will see how to solve such examples of variation. First example, 15 women finish the work of the harvesting a groundnut crop in 8 days. Find the number of the women if the same job is to be completed in 6 days. Now the solution. The number of the days required to finish a job is inversely proportional to the number of the women employed. Let the number of the days be D and the number of the women be N. Therefore, D is inversely proportional to N, and hence we can write here that is a D is equals to K upon N. Therefore, D into N is equals to K, where K is a constant of proportion. When N is equals to 15, D is equals to 8. Substitute here, then you will get the value of K. That is a 15 into 8 is equals to 120. Now let us see when D is equals to 6, then what is N? Therefore, D into N is equals to 120. Now substitute here, D is equals to 6, then you will get the value of N is equals to 120 upon 6, and hence N is equals to 20. Now the next example, that is a 20, therefore, that is again we can write here answer, that is a 20 women should be employed to finish the work in 6 days. Next example, a vehicle running at a speed of 40 km per hour takes the 6 hours to complete the journey. How many time will taken to complete the journey if the speed is 72 km per hour? Now here we are increasing the speed here. Therefore the time will be the less. Now let us assume that the speed of vehicle to be S and the time taken to travel be T. There is an inverse variation in the speed and time. Therefore, S is inversely proportional to T. S is equals to K upon T. S into T is equals to K, where K is a constant of variation. Now, first we have given that is a S is equals to 48, that is the speed, and the time taken is 6 hours. Therefore, 48 into 6 is equals to 288, which is the constant of variation. Now, let us find T when S is equals to 72. Therefore, the value of S is 72 into T is equals to 288. Therefore, T is equals to 288 upon 72, and that comes to the 4. Therefore, the time taken to travel the same distance at the speed of 72 km is 4 hours. Now, in the previous one, there were the 6 hours. Now, here is a 4 hours. The time is less now. Now, the practice set 7.3. Which of the following statements are of the inverse variation? The number of the workers on a job and the time taken by them to complete the job. This is an example of the inverse variation. Next, the number of the pipes of the same size to fill a tank and the time taken by them to fill the tank. This is an example of the inverse variation. Petrol filled in a tank of a vehicle and its a cost. Okay, and this is not the example of the inverse variation. Area of circle and its a radius. Again, this is not example of the inverse variation. Now, next is if the 15 workers. Now, why they are not the inverse variation? The first was the inverse variation, at the number of the workers and the time. If the workers are more, the time is less. Okay, therefore it is inverse variation. What about that? The number of the pipes of the same size to fill tank is and the time taken by them. This is again the inverse variation. If the number of the pipes are more, then the time taken to fill the tank is less. Therefore, it is inverse variation. Petrol filled in a tank of vehicle and its a cost. If we increase the petrol, then this cost will be the increase. Therefore, this is not the inverse variation, but it is a direct variation. Area of circle and its a radius. If we increase the area, that's its radius will also increases, or if we increase the radius, its area will increases. That is, one increases, another is also increases, and that type of variation is called the direct variation. But this is not the example of the inverse variation. Now the examples. If the 15 workers can build a wall in 48 hours, how many workers will be required to do the same work in 30 hours? Let the number of workers is n and the time taken by them is t. The number of workers and the time required to build the wall are in inverse proportion. Therefore, n is inversely proportional to t. N is equals to k upon t. Therefore, n into t is equals to k. When n is equals to 15, t is equals to 48. Therefore, what is the value of k? 15 into 48. Therefore, k is equals to 720. This is the constant of variation. Now, next he asks us, when t is equals to 30, then what is the value of n? Therefore, n into t is equals to k, which is 720. Substitute the value of t, that is a 30. Therefore, n is equals to 720 upon 30. And hence, n is equals to 24. Therefore, 24 workers will be required there. 120 bags of half-liter milk can be filled by a machine within 3 minutes. Find the time to fill 1800 bags. Okay. Now here time is t and the number of bags is n. The time required to fill the bag and the number of the bags are in the direct variation. If the time is more, the number of bags to be filled will be the more. Therefore, t is directly proportional to n. Therefore, t is equals to kn. Okay. Therefore, when n is equals to 120, t is equals to 3. Therefore, substitute here, t is equals to 3 and n is equals to 120. Therefore, k is equals to 3 upon 120 and hence k is equals to 1 upon 40. When n is equals to 1800, then what is the value of t? Now, this is the equation of the variation. That is, the t is equals to 1 upon 40 into n. Substitute the value of n, which is 1800, and after the calculation you will get here t is equals to 45. Therefore, 45 minutes are required to fill the bags 1800. Now the next example. A car with the speed 60 km per hour takes 8 hours to travel some distance. Okay. What should be the increase in the speed if the same distance is to be covered in 7.5 hours? Okay. Now let here the speed of the car is v and the time taken to cover a distance is t. The speed of car and the time to cover the distance are in the inverse variation. Therefore, v is inversely proportional to t. Therefore, v is equals to k upon t. Therefore, v into t is equals to k. v is equals to 60, t is equals to 8. Therefore, k is equals to 60 into 8. Therefore, k is equals to 480. Therefore, v into t is equals to 480. When t is equals to 7.5, then what is the value of v? That is, v into t is equals to 480. Therefore, v into 7.5 is equals to 480. Therefore, v is equals to 480 upon 7.5. And hence, v is equals to 480 upon 7.5 means what? 75 upon 10. And therefore, v is equals to 480 into 10 upon 75. And hence, v is equals to 4800 upon 75. And that comes to be 64. That is, to cover the same distance in 7.5 hours, the speed of the car should be 64 km per hour. Means what was the previous speed? Previous speed was the 60. Okay, see this here. The previous speed was 60. Now the speed is 64. That is, the increase in the speed is 64 minus 60. That is a 4 km per hour is the increase in the speed. Therefore, the speed of the car should be increased by the 4 km per hour. And in this way, we have completed the chapter variation, and I hope that you would have understood all the problems, whatever that I had explained. Now we'll see in the next video. Till then, goodbye.